Hi everyone, this is Mrs. GA, and today we're going to talk about dilations. So a dilation is a transformation that can change the size of a polynomial, but leaves the shape unchanged. So it's essentially, we're going to be taking a polygon or some image, and we're either going to kind of zoom in and make it bigger or zoom out and make it smaller, but it's going to look like the exact same figure, again, just a bigger or smaller version. So every dilation has what's called a center of dilation and a scale factor. So it tells you where to zoom in and out around, that's the center, and then the scale factor tells you how much to zoom in or out. And together you can use these to determine the position and the size of your image after the dilation. So if you look here, this is an example of a pre-image, ABC, and then its image, A prime, B prime, C prime. So if you look, this image inside, it looks exactly the same as the polygon that's outside. It's just your image is a little bit bigger. And you can see that they are kind of centered around that origin. We would expand about the origin, and I'll show you how to do that in just a moment. But this is an example of a dilation. So there are a few properties of dilations that you will need to know. First, it preserves the angle measure. So the measure of angle A should be the same as A prime, and so on and so forth. Next, it preserves what's called the betweenness of the polygon. So it's really the relative position of your coordinates. So here, B prime is somewhere between A prime and C prime. B is between A and C. They're kind of in the same relative area, and that ties into another one that we need to add. It preserves what's called the orientation of the shape, meaning it's not rotated around, it's not shifted up or down. Everything is in the same place relative to the other points. Also, it preserves collinearity, so any points that were collinear before should still be collinear. Dilations map a line segment, which is the pre-image, like AB, to another line segment whose length is the product, which remember means that we're multiplying, of the scale factor and the length of the pre-image. So this is how we're going to use our scale factor. We multiply it by the length of our pre-image, and we should get our image length. So it would be A prime, B prime. And last, dilations map a line not passing through the center of dilation to a parallel line and leave a line passing through the center unchanged. So let's look at this image again here. So this one has a center of dilation at the origin. So if I draw a line that goes from that center to A prime, you'll see that it also goes through A. So that line that goes through, whether it's going to A or A prime, it should be the same. So the same thing happens when I draw a line to B prime. You'll notice that it goes right through B, its pre-image coordinate. And same from the center to C prime. It goes right through its pre-image, which is C. So that's another way we can check to see if something is being dilated. Okay, so now let's look down here at example 1. Here we're asked to determine if the transformation is a dilation. If it is, then we're going to find the scale factor. So we can kind of go down this checklist. All of the angle measures are the same for the corresponding angles. I could see here that A is equal to A prime, B is equal to B prime, so on and so forth. The betweenness is preserved. So here C is between B and D, C prime is between B prime, D prime, so that applies for the entire image. It does preserve collinearity and the orientation. You can see that all of the letters are in the same relative location. And then we can also kind of test to see if we have that center of origin, which it looks like we do if we connect these lines. So that means that this is a dilation. So now we have to find the scale factor. So one way you can find the scale factor is by comparing the pre-image coordinate and the image coordinate. So let's use b and b prime. So our pre-image is at 0, 2. Our image is at 0, 3. So remember, this is the pre-image, and this is the image. And the scale factor is what we should multiply the pre-image by to get our image. So we can set up a little equation. So let's adjust for those y values that are changing. So it's 2 times k, or any variable you want, we'll use k for the scale factor, equals 3. So our pre-image times our scale factor equals our image. So if you solve, we get a scale factor of 3/2. And there you have it. Okay, let's look at another example together. So we're going to see if this is an example of dilation. So there's some of the properties do make this look like dilation. For example, all the angles are preserved, the betweenness is preserved, the collinearity is preserved, but you'll see that one key thing that is not preserved is the orientation. So what I mean by that is, if you look at your pre-image, P is to the right of N and M, and in your image, P prime is to the left of N prime and M prime. So that would make this not a dilation. And again, our reason for this could be orientation is not preserved. So anytime you have a translation or a reflection like you have here, it is no longer a dilation. Okay, so in this last problem, we're actually going to be finding the center of dilation, and then we are going to calculate the scale factor from our image to our pre-image. So here, the way you find the center of dilation is you're going to take your ruler and you're going to line up the corresponding points. And then you're going to draw a line that goes through and you're going to extend it. And then you're actually going to do that for all three. So you're going to do the same for B and B prime, and then for C and C prime. So I need to move my ruler to draw it, but you would actually use your ruler to do this. So your line should be a little bit straighter than mine. So you draw a line through each of the corresponding points, and hopefully you get a single point of intersection. So this point right here, we can label it point D. This is our center of dilation. Okay, so now we're going to take our ruler and we're actually going to measure the lengths from the center to our pre-image and the center to our image, and we're going to compare those lengths. So let's start by measuring DA and DA prime. So you take your ruler and line it up. So mine's a little bit off because my lines aren't perfectly straight, but let's say that the length of DA is about 6 inches and the length of DA prime is about 3. And now we're going to measure the length from DB and then DB prime. So again, we'll take our ruler, line it up, and we see that DB is about 4, and DB prime is about 2. And then last, we're going to do the length of DC and DC prime. So again, take your ruler, line it up. We can see DC is about 6, and DC prime is about 3. So remember, our scale factor is the number that we should multiply our pre-image by to get our image. So we can set up a little equation. Again, we could say 6 times k equals 3, and we get k equals 1/2. So you can either say a scale factor of 1/2, or you can actually say a scale factor of 1 to 2. So it's just a different way of wording it. All right, that is all for today's video. Thank you so much for watching.